Hi everyone, how are you today? Am I audible? So, a very good evening to all of you who have joined us today at GDSE Kalindi's Kickstart of ML Study Jams. And a quick heads up, we have planned today's session to be pretty interactive. We'll be playing games, we'll be watching videos, we'll be conducting quizzes. I'm hoping to hear a lot from you guys today. So, to start, I would like to hear how you've been. How are you today? How your day's been? Okay, so I'll be dropping a link in the chat box. This is the link to register for study jams, MS study jams with GDSE Kalindi. And if you haven't registered already and want the perks of attending ML study jams, want certificates, and want to collect badges on Kaggle and Crowdsource too, so you should definitely sign up for this. And we'll also be having like web study jams 15th onwards. We'll be doing MS study jams till 15th and some sessions after that too maybe. And after 15th we'll be basically focusing on web study jams, so you should definitely sign up for that too. The option is in the form itself. Okay, so before we begin today's session and get into machine learning, data science, and algorithms, I would like to ask you guys, what do you know about machine learning? Anything you've heard or anything you've learned about it? You can just share it in the chat box. Any ML enthusiasts or AI enthusiasts today who have joined us? Okay, so while we wait, I can tell you about machine learning. That machine learning is basically the decisions that humans make. Okay, so Ibrahim, we have uh, an answer from them. Train machine by providing data. Yes, we do train machine by providing it data, but train it to do what? We train it to make decisions. Decisions that uh, we have only learned that humans have the brains to make decisions, but with machine learning, we can train machines using data, like Ibrahim has just said, to make decisions on their own without supervision of humans or without the help of humans. So, to know more about this, I would like to share a video with you guys. So, I'll just be playing the video. It's pretty informative video.
Algorithms are all around you. You are watching this video because an algorithm brought it to you, among others, to click, which you did, and the algorithm took note. When you open the tweetbook, the algorithm decides what you see. When you search through your photos, the algorithm does the finding, maybe even makes a little movie for you. When you buy something, the algorithm sets the price, and the algorithm is at your bank watching transactions for fraud. The stock market is full of algorithms trading with algorithms. Given this, you might want to know how these little algorithmic bots shaping your world work, especially when they don't. In ye olden days, humans built algorithmic bots by giving them instructions the humans could explain. If this, then that. But many problems are just too big and hard for a human to write simple instructions for. There's a gazillion financial transactions a second. Which ones are fraudulent? There's octillion videos on NetMeTube. Which 8 should the user see as recommendations? Which shouldn't be allowed on the site at all? For this airline seat, what is the maximum price this user will pay right now? Algorithmic bots give answers to these questions. Not perfect answers, but much better than a human could do. But how these bots work exactly, more and more no one knows. Not even the humans who built them, or built them, as we will see. Now, companies that use these bots don't want to talk about how they work because the bots are valuable employees, very, very valuable, and how their brains are built is a fiercely guarded trade secret. Right now, the cutting edge is most likely very I hope you like linear algebra, but what the current hotness is on any particular site and how the bots work is a bit I don't know, and always will be. So let's talk about one of the more quaint but understandable ways bots can be built without understanding how their brains work. Say you want a bot that can recognize what is in a picture. Is it a bee or is it a 3? It's easy for humans, even little humans, but it's impossible to just tell a bot in bot language how to do it because really we just know that's a bee and that's a 3. We can say in words what makes them different, but bots don't understand words, and it's the wiring in our brains that makes it happen anyway. While an individual neuron may be understood and clusters of neurons' general purpose vaguely grasped, the whole is beyond. Nonetheless, it works. So to get a bot that can do this sorting, you don't build it yourself. You build a bot that builds bots and a bot that teaches bots. These bots' brains are simpler, something a smart human programmer can make. The builder bot builds bots, though it's not very good at it. At first, it connects the wires and modules in the bot brains almost at random. This leads to some very special student bots sent to TeacherBot to teach. Of course, TeacherBot can't tell a bee from a 3 either. If the human could build TeacherBot to do that, well then problem solved. Instead, the human gives TeacherBot a bunch of B photos and 3 photos and an answer key to which is what. TeacherBot can't teach, but TeacherBot can test. The adorable student bots stick out their tongues, try very hard, but they are bad at what they do. Very, very bad. And it's not their fault really. They were built that way. Grades in hand, the student bots take a march of shame back to BuilderBot. Those that did best are put to one side, the others recycled. BuilderBot still isn't good at building bots, but now it takes those left and makes copies with changes and new combinations. Back to school they go. TeacherBot teaches, tests again, and BuilderBot builds again. And again, and again. Now, a builder that builds at random and a teacher that doesn't teach just tests, and students who can't learn, they just are what they are, in theory shouldn't work, but in practice it does. Partly because in every iteration, BuilderBot's slaughterhouse keeps the best and discards the rest, and partly because TeacherBot isn't overseeing an old-timey one-room schoolhouse with a dozen students, but an infinite warehouse with thousands of students. The test isn't 10 questions, but a million questions. And how many times does the test, build, test, loop, repeat? As many as necessary. At first, students that survive are just lucky, but by combining enough lucky bots and keeping only what works, and randomly messing around with new copies of that, eventually a student bot emerges that isn't lucky, that can perhaps barely tell B's from 3s. As this bot is copied and changed, slowly the average test score rises, and thus the grade needed to survive the next round gets higher and higher. Keep this up, and eventually from the infinite warehouse slaughterhouse, a student bot will emerge who can tell a B from a 3 in a photo it's never seen before pretty well. But how the student bot does this, neither the teacher bot, nor the builder bot, nor the human overseer can understand, nor the student bot itself. After keeping so many useful random changes, the wiring in its head is incredibly complicated, and while an individual line of code may be understood and clusters of code's general purpose vaguely grasped, the whole is beyond. Nonetheless, it works. But this is frustrating, especially as the student bot is very good at exactly only the kinds of questions it's been taught to. It's great with photos, but useless with videos, or baffled if the photos are upside down, or things that are obviously not B's it's confident are. Since TeacherBot can't teach, all the human overseer can do is give it more questions to make the test even longer, to include the kinds of questions the best bots get wrong. This is important to understand. It's a reason why companies are obsessed with collecting data. More data equals longer tests equals better bots. So when you get the "Are you human?" test on a website, you are not only proving that you are human, hopefully, but you are also helping to build the test to make bots that can read or count or tell lakes from mountains or horses from humans. Seeing lots of questions about driving lately? What could that be building a test for? Now, figuring out what's in a photo or on a sign or filtering videos requires humans to make correct enough tests. But there is another kind of test that makes itself tests on the humans. For example, say entirely hypothetical NetMeTube wanted users to keep watching as long as possible. Well, how long a user stays on the site is easy to measure. So TeacherBot gives each student bot a bunch of NetMeTube users to oversee. The student bots watch what their user watches, looks at their files, and do their best to pick the videos that keep the user on the site. The longer the average, the higher their test score. Build, test, repeat. A million cycles later, there's a student bot who's pretty good at keeping the users watching, at least compared to what a human could build. But when people ask, how does the NetMeTube algorithm select videos, once again, there isn't a great answer other than pointing to the bot and the user data it had access to, and most vitally, how the human overseers direct TeacherBot to score the test. That's what the bot is trying to be good at to survive, but what the bot is thinking, or how it thinks it, is not really knowable. All that's knowable is this student bot gets to be the algorithm because it's 0.1% better than the previous bot at the test the humans designed. So everywhere on the internet, behind the scenes, there are tests to increase user interaction, or set prices just right to maximize revenue, or pick the posts from all your friends you'll like the most, or articles people will share the most, or whatever. If it's testable, it's teachable. Well, teachable. And a student bot will graduate from the warehouse to be the algorithm of its domain, at least for a little while. We're used to the idea that the tools we use, even if we don't understand them, someone does. But with our machines that learn, we are increasingly in a position where we use tools or are used by tools that no one, not even their creators, understand. We can only hope to guide them with the tests we make. And we need to get comfortable with that, as our algorithmic bot buddies are all around and not going anywhere. Okay.
Yes. I hope the video was pretty informative. So, what did you guys learn from the video? Anything new or things you've already known about? As we've already seen in the video, what we do in machine learning, we don't actually build the algorithm that can detect uh, whether it's, as in the video, whether it's a B or a three. We just build the algorithm that teaches that algorithm how to detect things, or like tests it basically. So, moving on, we have a quick game for you. And to play this game, you will have to visit this website, that is Crowdsource. You'll have to download Crowdsource app, or if you're on your laptops, you can just access it using this link. You can use it access this. You can use this link to access it, or if you already have it downloaded on your phone, or if you've already opened the Crowdsource app, you can use GDSE Kalindi's invite code that I've just shared in the chat box. By using this code, GDSE will know that you're affiliated with GDSE Kalindi and have been a part of MS Study Jams with GDSE Kalindi, and it will contribute with our community. Just let me know once you're done opening the app or opening it on your web. Okay, so once you're done, you can go to the smart camera task, and you can point your camera at any object around you. It could be, you can't point it at your phone. Well, if you're using a phone, it could be a glass, it could be a cupboard, it could be a lamp, it could be anything. You can just point it at something and check if the app recognizes the object. and let us know if the app recognizes the object or not. As you've seen in the video, we need data. Like the algorithm needs data, or to look at images to classify them. It needs that's called training data. It needs to train before, actually making predictions. If it has to, as we've seen in the video itself, if it has to predict what's a B or what's an E, it has to classify between them. It has to already look at images of bees or images of threes before telling us if the image that we're showing it is a bee or a three. So for I have PC with no webcam, then how can I do it? Oh, this task is actually not available on PC. This task is only available on if you download the app, but you can stay tuned for the coming task. There'll be more tasks which you can do with your laptop too. So the images we've we will be showing, or the objects we will be pointing our camera at, will serve as data for algorithms to learn or to train themselves and you know make themselves better. So did the app predict the object you were pointing it at? I hope it did. Also let us know if it doesn't. Okay, it did. Sharanya pointed it at something and it did. Anyone else? Okay, for just do it did. And this is it's a gamified version. This is crowdsourced by Google, and it's an Android and web app that allows users to answer quick questions in a gamified you this there are many tasks. This is the camera task that we have done. There are other tasks where you answer the questions or you classify images into categories. And this is a gamified version of a UI that helps generate diverse training data for machine learning. This the task that we've just done, it's like a testing if the algorithm can predict the object that you're pointing it at or not. And all of the data that Crowdsource has collected is available on open source too. On Crowdsource, you can answer simple questions and earn badges as you level up. And you can connect with contributors around the world. You can improve Google products for everyone by providing data to Google that will help the algorithms learn. So also, I've just mentioned that all of this data is available for anyone to use. I've just dropped the link to the open source data. There you go. I've just dropped the link to the data for crowdsource, and it's open source. You can use it in your projects. So we have something for everyone. We have something for beginners where they learn what is machine learning exactly and how we can go about it. And if you're already on a stage where you're building algorithms by yourself, we have things for you too. Like I've just shared an open source data set with you, and it's a pretty extensive data set. You can use it and you can improve your algorithms a lot by it. You can use your so why should you be a part of MS Study Jams? You can upscale your knowledge, obviously, and while you contribute on Crowdsource, there'll be weekly top five network contributors on Crowdsource app. So if you're one of the top five contributors, you will be on the leaderboard and you'll be acknowledged. And you also earn digital badges on Kaggle and Crowdsource. We'll be having sessions in the future where we'll be doing Kaggle sessions, and this on Crowdsource too. Once do tasks, you will earn badges there, and at the end of the completion of the course, you'll also earn a certificate. So now we have another game for you. As I mentioned, we have a lot of games in the bag for you today. Yeah, I have another game. This is a game where you can check if a neural network can recognize your doodling or not. I'll drop the link in the chat box. This is a pretty fun game. I've spent hours playing it. It's pretty addicting, but it's really fun. And you can actually see if your drawing is good enough because I am very bad at drawing, but it still recognizes my drawing, so it gives me some hope. Let me know if it recognizes your doodles or your drawings too. This game is pretty fun, by the way. Yesterday as I was playing it, I got prompts to draw a canoe or pliers or the ocean. It's pretty fun to play it. And this game has over 50 million drawings in the dataset, and over 15 million players have contributed. This dataset is also, available in open source. I'll share the link for that with you too. Also, any ideas how the neural network might predict your drawings or your doodles or what you're drawing? Are you guys playing it or not? Just listening to me go on about the game. So as you guys play the game, okay, Diksha is playing it. Diksha, what was your prompt? What did they ask you to draw? Oh, Nishta got 4 by 6. Pretty great at drawing. So let me just show you the data that's available. Just a minute. Right. So this is the data set of QuickDraw, and let's look at an apple. There are so many doodles of apples. You can even see there are 1,39,898 apple drawings on this website. These are by people who have doodled. And if you go to any doodle, let's check out this. Click on it, you can even see that this apple drawing is drawing number 64 and it was drawn in Taiwan on 23rd January 2017. So it's a pretty great data set. It's pretty extensive. You can even randomize it and see where you land. These are drawings of toes. Oh, and you can see snails or anything else you'd like. This is a pretty great resource for people who need data for their projects or research purposes. I also have a video for you guys, by the way, to understand how QuickDraw works. Let me play it for you.
Hi, I'm Jonas.
Hi, I'm Henry.
QuickDraw is a game a few of us at Google made. You draw, and the computer uses machine learning to guess what you're drawing.
I see square, or suitcase, or canoe. Oh, I know, it's shoe.
It's an experiment that uses some of the same technologies that helps Google Translate recognize your handwriting.
To understand handwriting or drawings, you don't just look at what the person drew, you look at how they actually drew it. Which strokes did they make first? Which direction did they draw them in? You train the computer on millions of characters from hundreds of languages, and over time, it learns whether you wrote look or whether you wrote book.
Training is a big part of how the computer can guess your drawings correctly. As people, it's easy for us to look at these three drawings and know they're all cats, but to a computer they're very different. One is just a head, one has a full body, and one is just facial features. To get the computer to understand, you have to show it a lot of cat doodles. And then it starts to see patterns, like that almost all doodles of cats have pointy ears, a small nose, and whiskers. Of course, it doesn't always work. That's because it's only seen a few thousand doodles. But the more you play with it, the more it will learn and the better it will get at guessing.
Oh, I know, it's cat.
We put it on the web for anyone to play with. We hope it inspires other people to think about fun ways to use machine learning. You can play it at g.co/AI experiments.
So, pretty great video, pretty great insight on how they've built the doodling game or the data collection thing. And so, how does ML work in Quick Draw? So, I've already shared the data set that it uses to predict your doodles. And if there are, as we've already learned, there are rule-based artificial intelligence or machine learning. Or in rule-based, like machine learning is not rule-based, artificial intelligence is rule-based. So in rule-based artificial intelligence, I'm audible, right? Right. So in rule-based artificial intelligence, where at first the programmers or developers frame the goal, like what's the goal of their algorithm or product, and then the designers and engineers develop flow and logic. For example, here they've used if or yeah, right, they've used if else, or you can even use for loop, while loop. All of these are examples of rule based algorithms, and they have to clearly define the rules in rule based algorithms. For example, if the object here they have shown that if the object height is greater than 10, they have to do x. If the object color is blue, they have to do y. If the object has two legs, it has to do z. So we have to clearly define. The algorithm doesn't learn by itself. You have anything that you have to change up in the algorithm or upgrade it, you have to manually make the changes in the code itself. You have to refine until the goals are met. But in machine learning, you have to frame the goal. Obviously, at first you have to frame the goal here too, but then you have to just train the model using examples. If you needed to differentiate between carrots and turnips, you have to just show it images of carrots, vast number of images of carrots and vast number of images of turnips, and then at some point it will be pretty great. Your algorithm or your what do you say, neural network would be pretty great at predicting whether it's a carrot or whether it's a turnip. And refine until goals are met. You can tweak your algorithm, but you can tweak your algorithm to upgrade it, but it will the best it will get is by learning, by looking at lots of data. You have to feed it new data every day to upgrade it. Now, a quick quiz. So, which approach do we have to use when we alphabetize a list of songs? Will we use rule-based approach or machine learning? Come on, answers in the chat. Any guesses? Alphabetizing a list of song titles, rule-based approach or machine learning? Rule-based. Okay, Bhavna says rule-based. Tejaswini says rule-based. So we are going with rule based, right? Final guess. Rule based. You guys were correct. Next question, ranking web search results. Will it be rule based or machine learning? Rule based again for this one, huh? Okay, let's see. Both. You can use both. You can use rule based approach, you can use machine learning approach as well. So next question, predicting house prices based on location. If you're predicting house prices, what will you use? Rule based approach or machine learning approach? Machine learning, okay. Let's look at the answer. Machine learning, you guys are pretty smart. Now, processing online payments. Pretty serious task processing online payments. So, will it be rule based approach or machine learning approach? Machine learning, both, both ML, machine learning. Okay, ML. Are you guys sure? Okay, let's look at the answer. Rule based. You'll use rule based approach while processing online payments because you have to be pretty accurate while processing online payments. You can't be even 1.1%, like 0.1% wrong. So you'll be using rule based approach while processing online payments. Next question, classifying an object in a photo. When you're recognizing an object in a photo, which approach will you use? Rule based approach or machine learning approach? Rules, ML, both machine learning, ML. Okay, let's look at the answer. Classifying an object, machine learning approach. As you've just seen in the video, they were classifying E and B. So they were classifying the object in the photo and they used machine learning approach. And so we'll be using machine learning approach as well. So, a quick recap of differences between rule-based approach and machine learning approach. Rule-based approach is where the rules are defined. You have to clearly define all of the rules, all of the parameters that the algorithm has to, do in different situations. And improvements come from algorithms and network. If you need to improve your uh, project, if you need to improve your algorithm, you have to manually make changes in the code so that it can upgrade. In machine learning, it learns patterns from data. You just have to feed it data, loads and loads of data, and it will improve from additional data. So both of them have its own benefits. We cannot use rule based approach everywhere. We cannot use machine learning approach everywhere as well. So both of them have their own benefits. In some cases we can use both of them. So both of them are pretty useful. Now, idea to implementation. If you already have an idea, an ML idea in your mind, and you have to implement it, how will you go about doing that? So first of all, you need to focus on the user. You need to identify what your user needs, and then after identifying what the needs of your user, you have to define the objective. Define the objective. For example, your user for example, let's take the example of Netflix. Okay, so focus on user. First of all, Netflix, we are the users in Netflix. So the Netflix will identify what the user needs. The user needs recommendations of shows or movies. So they will define their objective. Their objective is of providing recommendations of shows and movies. For that, firstly, they'll have to collect data. They'll have to collect data on the favorite shows of the individual, or what are the shows they've rewatched, what are the the kind of shows they search, what are the genres they usually watch. They'll have to collect data, and data collection, like predicting and evaluating and training and test modeling are important tasks, but most of your time will be spent in collecting the data and fine tuning the data to better your model. Because collecting data, while collecting data we have to keep some things in mind. For example, your data cannot be biased. Your own biases, the human bias, every human has some biases in their mind. There's no question about it. We have to make sure that the biases that we have are not transferred to the data. We have to make sure that our data is unbiased, and we have to keep improving the data. We have to collect new data every day. In the case of Netflix too, for example, you know if someone watches horror, and they have watched horror for years, but suddenly they start watching, maybe, what, like, life changing shows. What can I say? Okay, they start watching romance. So the data has to be upgraded, the data has to be modified or altered to make sure that the recommendations they are getting also include romance titles or the genre. Now, most of your time will be spent fine tuning, collecting, modifying, altering the data. Also, while collecting data, we also have to make sure that it's private. We have to make sure that the privacy of the users, of the individuals that we collected data from, is respected. And after data collection, we move on to training and test modeling. So the data we have collected, we use that to train our algorithm that we have built, and then we test it. We test the model. We test the model on new data, on data that we have not used for training, and then the data predicts in a case of Netflix, it provides the recommendations, and the user, if the user clicks on it, if the user watches the show, that means that the algorithm was successful. If it wasn't, if it is recommending shows that are not the type of shows that the user might watch, then the data collection, like this process, will keep repeating and keep on repeating until the end of time, maybe. After predicting and evaluating, we go back to the first step, and we also go back to data collection. If the algorithm keeps on collecting new data, like, we need to keep feeding new data to the algorithm constantly. I also have a video for you guys on privacy, how important privacy is while collecting data. So let me just share the video with you, because most of your time will be spent on collecting data and altering it. Data collection is the most important part. You need to have a really good data set for your model to be perfect. Models can't be perfect, but your model to be pretty good. Where can I get profile link for the Crowdsource account? Right, I'll share it once again in the chat. I'll put on the video for you guys and then share the link.
Machine learning systems require lots of data to make successful predictions. What happens when that data is sensitive, such as people's names, credit card numbers, or medical histories? Sometimes, sensitive data is needed to train a model so it can make accurate predictions. But at the same time, this data must be carefully protected. This is the challenge of machine learning privacy. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis the common cold, whereas someone else with the same symptoms plus a high fever might be diagnosed with the flu. Plenty of other factors might influence the diagnosis too. Does the patient have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people and their symptoms. medical records, and demographic information. This data includes plenty of personal information that needs to be kept private. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card numbers used to pay healthcare providers. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your datasets that may be sensitive. For example, people's names, addresses, telephone numbers, email addresses, government ID numbers, and other personally identifiable information, or PII, should be kept private. Another type of private information is user generated content, such as email messages, YouTube videos, blog posts, and any other content created by known individuals. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to use the data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, you build trust with users and protect your company's interests.
So now we've seen the importance of data collection and what machine learning basically does. So moving on to what can machine learning do? With machine learning, you can do a lot of tasks. You can do classification, you can do regression, you can, transfer styles. You can do a lot of stuff. So before we get into what methods of machine learning we can use or what machine learning can actually do, first you have to understand what is artificial intelligence, what is machine learning, and what is deep learning. So these are interlinked, and people, mix them up a lot of times, but these are actually slightly different. So artificial intelligence includes machine learning, and machine learning includes deep learning. What is artificial intelligence? Artificial intelligence is when you teach a machine, or when you artificially program a machine for it to be intelligent enough to make its own choices. This can also be done without machine learning. For example, the rule based approach we have talked about previously, the rule based approach, like your if else, your for loop, your while loop, all of that is also included in artificial intelligence. But in machine learning, machine learning is data based. In machine learning, you have to provide data to the algorithm that you build, and it learns based on the data. It learns by recognizing patterns that are present in the data. So for machine learning and deep learning, the difference between them is in machine learning you have to provide, parameters. If you have to differentiate between a lion and maybe a fish, you will have to provide parameters. You will have to provide a CSV file, for example, how long the lion's face is, or what is the size of his eyes, what or how long the fish's tail is. You'll have to provide specific numbers. You'll have to talk to the machine in numbers. That's the data you'll be providing. You'll have to provide a CSV file in machine learning. Whereas in deep learning, you can just provide it images or videos or audios. You do not have to do the task of, converting the data in the form of images or videos or audio into a CSV file. You do not have to do that task. You can completely skip over it and use deep learning instead of machine learning. So deep learning minimizes the time that you have to put in while programming the algorithm, and it also gives pretty great results. So, what can we do with machine learning? Firstly, we can do classification tasks. In classification tasks, this method predicts or explains a class value. Here, it has predicted that from the image that it's a lion, it's a wildlife animal, and it's a mammal. So the blue dots that you see here, this line that goes between the red dots and blue dots is the classification line. This is the threshold that the image, needs to cross, the threshold that the image needs to cross to end up in a class. For example, if it's a lion, if the image here is a lion, this this line will classify it. This image will be on another side of all of the dots here are images of lines, and all of the dots here are not images of lines. Next, we can do regression. Regression helps to predict or explain a particular numerical value based on a set of prior data. For example, if an ice cream company needs to predict which will be the highest selling ice cream in summer 2022, so for that they will have to provide the data of all the previous years of all the ice creams that have been purchased, of the sales of them, and then design an algorithm through feeding that data into it and predict that which ice cream will be the most popular or the most sold during the coming summer. Any questions so far? Any questions before I start explaining what clustering is and the upcoming styles? Is it getting boring? Okay, so no questions, I assume. Uh, Next, we come on to clustering. Clustering groups data points according to similar or shared characteristics. For example, it can group fans of a show into one group. It can group, fans of, like, people who like specific things or people who share specific characteristics. The a cluster of people who are a part of a university or your college are also a group. Clustering can also be used to group individuals in the same group. Or for example, here we can see the example sevens and twos. They look pretty similar, like the strokes are pretty similar, but they are still different. Since they are pretty similar, they are clustered in the same group by the algorithm. Next is sequence prediction. Sequence prediction produces a sequence of values from a set of input values. Now it predicts what will come next. It's different from regression because it's not necessary that it predicts continuous values. It can predict the alphabet that will come next, or your uh, what's that called, prediction, text prediction that you use while texting. It tells you which letter might become next. You type HE and it predicts hello. That is also a part of sequence prediction. Uh, Sequence prediction uses sequential data, that is, the points in the data set are dependent on other points in the data set. So the data is interconnected and no value is isolated in sequence prediction. Next, we have style transfer. In style transfer, the styles of the data fed to the algorithm are recognized by the algorithm, and it tries to replicate the style of the data. Here we can see that this algorithm has been fed these two images and has tried to replicate the style of both of them and produce a single image through that. doubts or any questions before we move on to our next quiz part? Okay, so the question you can see on the screen, recommending next word in the Android SMS app based on the words typed so far. Which type of machine learning is that? Recommending the next word. This is like basically text prediction. So, what do we use for text prediction? Do we use classification, clustering, regression, sequence prediction, style transfer? What do we use? Any guesses? Okay, sequence prediction. Let's see. All of you are correct. It's sequence prediction. Now, the next one is labeling email as spam or not spam. Spam, I will not say the answer. The spam filter in your email, what is it? Classification, is it clustering, is it regression, sequence prediction, or style transfer? Classification, okay. Again, you guys are correct. You guys are pretty smart. Why I like do you guys already know this stuff or have you learned something today by joining this session? So next question is, which type of machine learning is used when identifying trends amongst a group of people who have got a new music release? Ibrahim says they have learned. Okay, that's great to hear. Which type of machine learning will be used here? Clustering. Okay, Asta says clustering. Let's check out. Okay, it's clustering. Asta was correct. Next question, a bot that reads the news in the voices of famous actors. Which one will it be? Classification, clustering, sequence prediction, regression, style transfer. What does a bot do when it reads the news in the voice of a famous actor? Style transfer, okay, classification. Let's have a look at the answer. Style transfer, pretty neat guess. Next question, determining workout activity based on phone movement. Bhavna says style transfer. Bhavna, are you answering for this question or the previous one? Okay. Regression, classification. Any other guesses, or should we move on to the answer? Sequence prediction or regression? Confused in this one, right? This one's pretty confusing. Regression. Determining workout activity based on form movement. It's classification. This one is pretty confusing. I was confused too while looking at the PPT, but this one is classification. You have to, in this case, you have to basically feed the data of how the phone moves or how the body moves while doing different workout activities, and then the algorithm classifies the activity into classes. You have to make classes. For example, if someone is doing push-ups, there has to be a class is basically a folder. There has to be a folder of movements or maybe videos or how the phone moves while the person is doing push-ups in that folder. If someone is doing pull-ups, there has to be a separate folder where the data is present of how the phone moves while the person is doing pull-ups. Same goes for running. There has to be a folder for running. There has to be a folder. There has to be a folder for swimming. There has to be a folder for jogging or planks, and there has to be a separate folder for everything. That is the classes. And when you feed that data to the algorithm, it learns or it recognizes the patterns of of the phone movement. It recognizes the phone movement that is made while doing different workout activities, and then when you present it with new data, that is the testing data, it can classify that movement into a class. Nishita, is it clear now? Okay, great to know, Nishita. So, next one. Which type of machine learning is used when identifying famous landmarks in a photo? Like, how can a photo tell you that, like, how can the algorithm tell you that you're looking at a photo of the Taj Mahal or the Eiffel Tower or the Leaning Tower of Pisa or Qutub Minar, maybe? Which type of machine learning will it use while doing so? Astha says classification. Okay. Vanchika, Ibrahim say classification too. Soumyadeep says sequence prediction. So the answer is classification. Now, moving on to the next question. Suggesting spelling corrections, or basically autocorrect that we use while texting or typing. Which one will it be? Nishita, for clustering, if you were answering it for the previous question, for this one where you identify famous landmarks in a photo, clustering will be when the algorithm is predicting the you know whether the object that we are looking at in the picture is a famous landmark or not. That will be clustering, maybe because it's grouping all the landmarks into a folder or clustering it. But when it's identifying the landmark, it's telling us that you see Taj Mahal in the picture. It's telling us that you see Eiffel Tower in the picture. That will be classification, because there will be different classes for every landmark. There will be a folder of images of Taj Mahal. There will be a different folder for images of Eiffel Tower, there will be a different folder for images of Qutub Minar. So this one will be classification. Now this one, as most of you have said, sequence prediction. Okay, let's have a look. Clustering. How this will be clustering? Let me tell you. This will be clustering because spelling corrections, like if you're typing hello and you have typed it as GELLO instead of HELLO. G is pretty close to H, or if you've typed HEKLO, K is pretty close to L. So all of the common spelling errors that individuals make will be clustered, and all of them will be recognized as hello. So if you make a spelling error while typing hello, it will have, if you type it GELLO, it will have a look at which cluster it belongs to and see that it belongs to the cluster of hello, and then it will correct it to hello. Same goes for any other word. It could be a different word. It could be balloon, right? It could be balloon. If you type a single O, if you type BALLON in balloon instead of BALLOON, it will, have a look at which cluster the incorrect spelling belongs to, and then it will see that, oh, this spelling belongs to the cluster of balloon. So it will correct it to balloon. Is that clear now? Sequence prediction is basically used when you are predicting the next word. If you type hey, the next word could be there, so it can predict there. Or hey, it could the next word could be you. You might have been typing hey you, or it could be an exclamation mark. It's predicting the next word. That will be sequence prediction. But when it's correcting spellings, it will be clustering. Okay, pretty good to know that you guys are actually understanding what I'm saying and it's knowledgeable. So, next one, predicting the quality score for an advertisement. So, this is basically predicting the quality of the advertisement or how successful the advertisement will be. So, which one do you guys think this will be? Okay, Ibrahim is guessing regression, Nishita, Bhavna, all of them are saying regression. Manchika, I'll clarify your doubt at the end of the session. Is that all right? So moving on to this one, let's have a look at the answer. Correct, it will be regression because they're predicting, or yeah, they're predicting the quality score for an advertisement. It will be regression based on the data that of the previous advertisements or the quality score of the previous advertisements. Next one, estimated arrival time based on time of day and traffic. Any guesses? This is basically Google Maps. Like when you enter a location and it estimates the arrival time. Which one do you guys think this will be? Okay, we have regression and clustering as guesses, so that we have a majority. No problem if you're wrong. We're here to learn. Okay, Nishita says regression too. Let's have a look at the answer. It's regression. So Asta and Nishita are correct. And it's not clustering because in clustering you would be, assigning it to a group. You won't be assigning the estimated arrival time in a group. Ibrahim, you can maybe elaborate on how you thought it was clustering so I can help you clear up the doubt if you want. So, next one. Which type of machine learning is translating between two languages? The translation task, Google Translate, or any other translating app or resource that you use? Which one will it be? Style transfer. Okay. Sequence prediction. Translating between two languages is sequence prediction. I'll share a resource by which you can understand how translating between two languages in sequence prediction is sequence prediction. So I'll be sharing that after the session. If that's all right with you guys, you can have a look at that and see or learn. So thank you, and that's it for today's session. You can drop your questions, your doubts if you have any in the chat box. You can tell me how you thought the session was. Also, make sure to fill this form that I'll just be dropping in the chat box. Right. This form, you'll have to fill this out before the 15th so that you are, eligible for the certificates and other stuff that you'll be receiving after completing ML study jams. Sure, Astha. We'll share the questions. We'll share these questions and the resources, all the videos and other resources too. We'll share a doc with you guys. Thank you, Kiran. Also, we'll be conducting, a lot of sessions, and to know about them, we'll be conducting more sessions on with emissary jams too, and then after that we'll be having web jams. So to know about them, you can connect with GDSC Kalindi on its different socials. You can connect with us on Discord, on Telegram, on LinkedIn. So thoughts on today's session, and make sure to connect with us. You will know about all of the upcoming sessions of GDC Kalindi if you connect with us on maybe Discord or Telegram or any other platform that you're comfortable with. Right, Vanshika's doubt, I forgot about this one. But here it will check the sequence of letters, like hello, it will check letter by letter. That's why I said sequence prediction. Vanshika, in that case, in the case of hello, it will look at hello as a whole word. If you type H and E, then it will predict that, oh, maybe you're typing hello. But if you have already written hello, if you have written the incorrect spelling of hello, you've written GELLO, then it's it recognizes that that spelling is a part of the cluster which belongs to hello. Spelling correction will be when you are done typing the word. Prediction will be, or sequence prediction, or the case that you're saying, the example that you are mentioning, that will be when you're still typing the word. I hope that's clear, and you can reach out to me later too if you still have a doubt. So that's it for today. Thank you for joining, everyone. See you in the next session. Have a great day.